Tidal Activity. In this unit, we will study tidal activity, high tide and low tide. Initially, we will find the places that show greater tidal activity than others. Then, we will examine the frequency and periodicity of the phenomenon, reaching the conclusions. The map below shows the tidal activity with the colors that describe the amplitude in meters in the oceanic and coastline areas. Tidal phenomenon in general. The sea currents and the water masses of the seas are affected by the electromagnetic field created by the Moon in relation to the position of the Sun. What happens is that we have the sea level rise for 6 hours and a few minutes, then we have the water stagnate for about 10 minutes, and then we have it recede for the same amount of time, with the stagnation remaining at the bottom for another about 10 minutes. In other words, we have an oscillation of the waters with comparable frequency and periodicity. In some observation points, the range of the phenomenon is larger and in others smaller. The tidal wave always comes from the east and goes west following the Moon. When this wave enters a bay with unequal openings and with a different orientation, a different speed of activity is observed, as a result of which we have phenomena of alternating water movement every 6 hours and a few minutes. The Moon affects the phenomenon in a geographical part more as it passes nearer the meridian of that part. The new moon, as well as the full moon, affect the phenomenon more, as well as the phases of the Moon that are nearby. On the day of the new moon and the full moon, we have the peak of the phenomenon. On the contrary, for the first quarter and the last quarter of the Moon, as well as the days before and after them, the phenomenon becomes irregular, presenting a mess. In this case, we may have zero influence and the phenomenon may not be observed for a day or two. The periods of this disorder are observed twice in a lunar month and last for a period of 3 days. The first period of disorder includes the 7th, 8th, and 9th lunar days, while the second, the 22nd, 23rd, and 24th. After periods of disturbance, the waters do not acquire high tidal velocities, so when we have the so-called conjunctions, we have a greater range of tidal activity, while in Quadrature, the currents caused are weaker, or even, if the barometric conditions and the configuration of the coasts and seabeds play a role, irregular. Tides and great depths. By studying the relief of the ocean depths, and particularly in the coastlines where they are marked on the map, we find that in the areas where a wide range of tidal activity is observed, there is a large sea gap or a deep trench or a super deep crater depth very close by in the sea that is near there. In contrast, we have a significantly lower range of tidal activity in marine areas with relatively shallow depths and on these surrounding coasts. In this way, we see that there is a relation between the depth of the oceans and the range of the tidal activity caused there and in the adjacent coastal areas. We notice that the great depths marked are responsible for the large range of tidal activity at these points, but also in the surrounding coastal areas. This phenomenon can be local or widespread. On beaches, where the sea is deep, the phenomenon is done with a large scale. The phenomenon of tides happens due to the properties of water that receives electromagnetism and frequencies. Water is a diamagnetic medium that accepts and affects electromagnetism and frequencies. The cosmic energy that comes from below penetrates the surface of the Earth, creates the Moon and the Sun at the boundaries of the ether with a material field. It affects more the great ocean depths due to a more direct effect and a closer distance with the source. Periodicity and alternative electromagnetic tidal zones. Coastal areas experience 2 low tides and 2 high tides every lunar day. As the Moon is making its spiral orbit, Two tidal waves are moving with it, creating high and low tides. The phases of the Moon affect the maximum range of tidal activity, giving even greater values when the Moon is full or new, and minimum range on first and last quarter. The phases of the Moon are also directly linked to the position of the Moon and the Sun on the constellations. One lunar day is 24 hours and 52 minutes, and in one lunar day the Moon makes a full circle in the component of circle motion of the total spiral motion. High tides are created at the areas below and opposite the Moon, and low tides at the other areas beside this, as we can see below. As the Moon moves, it takes these tidal zones with it, and thus the phenomenon acquires a dynamic with a specific frequency and periodicity. We see that the surface of the Earth is divided into 4 moving quadrants, which alternatively mix the electromagnetic repulsion with the electromagnetic attraction between the line created by the Moon and the source of cosmic radiation coming from below. Areas below the Moon and opposite, relative to magnetic north, and in these quadrants experience electromagnetic repulsion, high tides and high water levels. Areas in adjacent quadrants experience electromagnetic pull, that is low tide and low water levels. Tidal electromagnetic behavior. So we can see that the existence of the Moon, together with the cause that creates it, cosmic electromagnetic energy from below, with the spiral movement of the Moon, is creating a sinusoidal field which affects the masses of water, either attracting them or repelling them with a specific frequency and periodicity. The fact that the phases of the Moon affect the magnitude of the phenomenon, as we said before, means that the position of the Sun also affects the phenomenon, and more precisely its position in relation to the Moon in the constellations. When we have conjunctions, the effect is intense, while when we have squares, the effect disappears. So we conclude that the cosmic electromagnetic frequency affecting the water masses is altered and maximized when the Moon and Sun align. The full phenomenon repeats itself every 12 hours and 25 minutes, while its frequency in one lunar day is equal to 2. This field, due to its sinusoidal form, creates local maxima and minima in the electromagnetic force exerted on the water masses, resulting in a positive or negative momentum in them, creating floods and ebbs respectively. Seawater masses located at great depths are more affected and provide more space for the phenomenon to spread. The vast depths of the oceans actually rest on the background of the Earth at their bottom, so in those places we have a great effect of this electromagnetic force. In this way, coastal areas that have a deep sea nearby have a large range of tidal activity, while coastal areas with shallow seas much less. This phenomenon is an electromagnetic phenomenon, since electromagnetic phenomena cause it, cosmic energy coming from below in the Moon. It is the cosmic breath of the Earth, where all the sea masses and also the coastal areas are affected, renewing the original conditions. Great depths influence. In this map, we see the huge depths of the seas that affect the nearby coastal areas, creating locally high tidal activity there. The tidal phenomenon seems complicated, but in fact, it is not difficult to understand. To fully understand and cover the phenomenon of tides, we will see some examples with maps. The Moon itself to identify the extreme depths where they are responsible for the large local ranges of activity as the Moon passes through these areas, being in various phases. At the same time, we will see what is happening in other distant or nearby areas, explaining the reason for the intensity of the phenomenon. In other words, we will do a review of the tidal zones and the electromagnetic field that the Moon itself is a result of. Example 1. In our first example, we have the Moon passing over Asia where it is seen in the image. As the Moon is a result of electromagnetism and ionization, carries with it the maximum of the electromagnetic field that creates it. Thus, as we saw before, a frequency and periodicity is created in the rate of change of the influence of this field on the sea masses. The Moon, in our example, is full, and just like when we have a new moon, it is the conditions that favor the phenomenon the most. If the Moon were on a course further south and closer to the latitude of the deep Indian Ocean, we would have an even stronger tidal effect because the oscillating vertical electromagnetic field would be closer to these depths. Here we see in the Indian Ocean the relief of the deep, which gives high tidal activity mainly on the coasts of northern Australia or Thailand Gulf, and less in the Bay of Bengal or West Australia, while some great depths north of New Zealand affect the coasts there. India from the east does not have big tidal ranges because the waters are relatively shallow, while to the west, due to the huge sea trench that extends from the center of the Indian Ocean to there, as well as two large crater holes on the seafloor there, it has large. Generally, the very white areas of the Moon map are huge depths in the ocean, so these points, when they are close to some coasts, affect them the most in the range of tidal activity. Example 2. Here in this example, we have the Moon north of the equator over Northwest Africa up from Western Sahara. We again examine the phase of the full moon, which, as in the new moon, we have the greatest breadth and spread of the phenomenon. In the case of the full moon, the Sun is opposite the Moon in the constellations, and we have an alignment. We also have an alignment at the new moon as the Sun is in the same constellation as the Sun. This seems to help the development of the phenomenon as we have the maximum activity values. As the Moon moves from east to west, the arrow shows the tangent of its orbit at this point. It takes with it the tidal zones where they affect the water masses differently in places. The land is divided into 4 quadrants. The one below the Moon and anti-diametrically opposite to magnetic north have high water levels and high tides, while the other 2 adjacent quadrants have low water levels and ebb tides. Here we see that the sea areas of the Atlantic Ocean that are on the European side of Alaska belongs at this particular time to the high tidal quadrants 1 and 3, while the Atlantic areas that are on the West American side have a low tide. It seems as if the super bottomless depths of the oceans act either as undersea springs or as whirlpool, changing their function every 6 hours and 12 minutes. The Sun is the regulator of this function, while the alignment of the Moon with the Sun maximizes it. The phenomenon of tides is due to electromagnetic cosmic frequency oscillation that clearly affects the water of the seas. Example 3. In this example, we see the area further south of South America, namely the Southwest Atlantic and Southeast Pacific Oceans. The Moon is in the new moon phase, where we also have the maximum influence, as well as the full moon, on the tidal phenomenon. Due to the phase of the Moon, the Sun is in the same constellation as the Moon, and they walk together in their separate spiral orbits. In our example, the Sun is near the equator, while the new moon is further south, as we can see below. As the Moon comes towards this region, it takes with it the tidal wave, which is the result of the oscillation of the vertical electromagnetic field affecting the water masses. As we saw in the quadrant that is under the Moon and in the anti-diametric opposite, we have a high end in the oscillation that creates floods, while in the adjacent quadrants there is ebb. In other words, the tidal wave moves with the Moon's movement and affects the depths more. In the South Atlantic, seeing the texture of the seabed from the map offered by the Moon, we find that there are no great depths there, only shallow waters. On the contrary, on the South Pacific side, we have deep water and a large gap. Trans Canyon is located south of South America towards the eastern Pacific side. Thus we see that the eastern coasts of South America do not receive a large range of tidal wave, while in the south of South America we have a very large range of tidal activity, which certainly affects more southern Fuego and less southern Lacache. Example 4. In this example, the Sun is between West Africa and Atlantis. The Moon is at first quarter and is 90 degrees or 3 constellations behind the Sun. Thus, it is located in the Indian Ocean approaching East Africa and its coasts. As we have seen, we have a case of Quadrature, the Sun with the Moon, and thus the tide effect has a small or even zero range. The tidal zones are created again, but due to the minimal intensity of the electromagnetic field in the phases of the first quarter and the last quarter, it does not affect the waters except at the very extreme depths, and there very little. So this pulsating electromagnetic field loses its intensity when we have the Sun relative to the Moon at an angle close to 90 or 270 degrees. In other words, we are talking about a pulsating electromagnetic field of varying intensity of a specific dynamic form with a specific frequency and period. Looking at the texture of the seabed on the coast of South Africa, we see shallow seas that do not favor the wide range of tides. On the contrary, in the Indian Ocean towards the Arabian Sea, we see some great depths there. On other lunar days, the phenomenon is intense. Example 5. In the last example, we will broadly see the phenomenon of tidal zones for a bigger part of the Earth. In this example, we have a 2-day moon, which phase is close to the new moon, and so we have quite a wide range of tidal activity. On the second lunar day, the moon trails the Sun by a very small angle, and for an observer, the moon sets about an hour and 40 minutes later. In the places that are in the quadrant of the moon, but also on the opposite side, and especially in coastal areas that border on some great depth, we have a flood. The areas that are in the adjacent quadrants show a low tide, and again, in the same way, greater those that border the great depths. The coasts of all the coastal areas of the Pacific, in our example, have high tide, while the coasts of America towards the side of the Atlantic ebb. On the other side of the Atlantic, a high tide occurs in the east because it is opposite the moon at the time we are studying in our example. The coasts of the regions of Asia, Australia and Africa, where they are weighted by the Indian Ocean, have a low tide because they belong in an adjacent quadrant at this moment. This whole situation is constantly changing because these zones move with the moon, making a full rotation in 24 hours and about 15 minutes. Thus we have 2 floods and 2 ebbs in one lunar day.